All right, we're going to start out just working with some basic arithmetic and leading into the order of operations. We'll begin with some addition and subtraction. And, you know, the basic idea here, and I'm going to say this probably a million times over the course of these modules, is we got to be careful with our signs. So, you know, for adding integers that have the same sign, we basically just add the integers, and the sum adopts the sign of the two integers. So negative 11 plus a negative 5, 11 and 5 is 16, and this gives us a negative 16. We have sort of a visual way to understand this. If I start out at negative 11 and I'm adding negative 5, they're just saying go back 5 more spots. And so that brings us to negative 16. When we're adding integers with a different sign, basically we're going to do some subtraction, and then the difference will adopt the sign of the number with the biggest absolute value. So 13 plus negative 6, and this is equal to 13 minus 6, which is a positive 7. Again, we do have kind of a visual way to represent this or understand this. I'm starting at 13, I'm adding a negative 6, meaning I'm going to go back 6 spots, and that puts me here at a positive 7. When we're subtracting numbers, basically, it's just subtraction is defined in terms of addition, just adding the negative. So again, be careful with your signs here. 17 minus a negative 11, if I'm subtracting a negative, that's going to be changed to adding, and then the number I get when I change that sign, so adding a positive 11. And that gives us a positive 28. Negative 18 minus a negative 5. Well, this is negative 18. That stays the same. Minus a negative 5. That's plus 5. And negative 18 plus 5. I'm going to do the subtraction, and that gives me 13. And the number with the biggest absolute value is the negative 18. So this is a negative 13. Again, we could, you know, have a visual representation. I'm starting out down here at negative 18. I'm adding a positive 5, so this time I'm going to go in the positive direction. And that leaves me here at negative 13. And then this problem looks similar to the last one, negative 18 minus 5, but this time I'm subtracting 5. I'm not subtracting negative 5. So negative 18 minus 5, that's going to give me a negative 23. Visually, we could think of it as starting out at negative 18. And this time I'm subtracting 5 or adding a negative 5, so I'm going to go back 5 spots. And that puts me here at negative 23. Multiplying and dividing. Again, be careful with your signs. If we're multiplying or dividing two numbers that have the same sign, we always get a positive. If we're multiplying or dividing two numbers with a different sign, we are always going to get a negative. And then 0 is kind of a special number. So if a is a non-zero integer and I multiply it by 0, we get 0. If I take 0 and divide by any non-zero integer, I will always get 0. But if I take any non-zero integer and I divide by 0, the result is undefined. We cannot divide by 0, so we should just keep that in mind. All right, let's do some examples. Negative 5 times negative 10. Well, 5 times 10 is 50. They're both the same sign, so it'll be a positive 50. 80 divided by negative 4. That's going to be a negative. 80 over 4 is 20, negative 20. 0 divided by negative 3 is 0. 0 on top of a fraction, that makes the whole thing 0. And then negative 6 divided by 0, well, this is undefined. We cannot divide by 0. All right, working with some fractions. Multiplying and dividing fractions is fairly straightforward. When you're multiplying fractions, all you're going to do is multiply the tops, put it on top. And then you're going to multiply the two numbers on the bottom, put them on the bottom. You always want to do any reducing that you can, like canceling common factors. And when you're dividing fractions, your first step is to turn it into a multiplication problem. So a over b divided by c over d, I'm just going to change that into the product by flipping over the second fraction. And then it becomes a multiplication problem, which we know how to do. So in part A, 3 halves times 5 sevenths, so this will be 3 times 5 over 2 times 7, or 15 over 14. I always leave my fractions like this. Some folks ask, should I write this as 1 and 1/14, like change it to a mixed number? And I say, it's not incorrect. I mean, that's certainly equal, but it's much more conventional to leave it as what we would call an improper fraction. These are much easier to work with, and you'll see they're used a lot more in mathematics than writing something as a mixed number. I always like to start, if possible, by factoring. So 15/14 times 21 over 12. I'm going to just factor each of these numbers. 3 times 5 is 15, 14 is 2 times 7, 21 is 3 times 7, and 12 is 3 times 4. And I guess I could write 4 as 2 times 2. So possible, I usually go all the way down to primes. And then I just cancel whatever will cancel, which is not a whole lot, but I can cancel 3, I can cancel the 7. Notice with the 7s, they weren't in the same fraction initially. Now if you're multiplying two fractions, you can cancel a common factor as long as one is on top and one is on the bottom. They don't have to be in the same fraction. And what that leaves me with on top is 3 times 5, or 15. On the bottom, 2 times 2 times 2 is 8. 3 halves divided by 13/12. I'm going to first start out by writing it as a product, and then I will proceed by factoring. So 3 halves times 12 is 2 times 2 times 3. I can cancel one of these 2's. On top, 3 times 2 times 3 is 18 over 13. All right, if we're adding or subtracting fractions, we have to have a common denominator. We don't need a common denominator when we're multiplying or dividing, and in fact, getting a common denominator if you're multiplying or dividing just makes the problem harder. But if we're adding and subtracting, we need a common denominator. It's like having a common unit. We want to add apples to apples here. So I'm going to start by factoring just the denominators. So 6 is 2 times 3. 4 is 2 times 2. To get a common denominator, I'm going to just look over here and say, okay, what's present in the second denominator that I don't see over here in the first one? And it's missing a 2. We want to have all the same factors and the same numbers of each factor, so they both need 2 2's. And then I ask the same question, going the other way, what's present in the first fraction that's not present in the second one? And that needs a factor of 3. So now I can rewrite this problem as 2 over 12 plus 3 over 12. If you already have a common denominator, you're going to just bring that denominator over and then perform this operation on the numerator. So we end up with 5/12 as a result. Let's try another one. Again, we're going to start just by factoring the denominators. So 7, 2 times 2 times 3, minus 2 9s 9 is 3 times 3. The first fraction needs to pick up a factor of 3. I'll throw that in there. And then the second fraction needs to pick up both those factors of 2. So my denominator is 4 times 3 36. And up top I have 7 times 3, which is 21, minus 2 times 2 times 2 is 8. 21 minus 8 is 13. All right, so we'll talk a little bit about exponents. We're going to spend a bunch of time on exponents in a little bit, but now we're just going to do enough now to define what they are so we know how to interpret it. A to the n power just means I have n factors of a. I'm multiplying a by itself that many times. We have to be really careful with signs, and in particular we have to be careful about if something is a negative, does it appear inside a set of parentheses being raised to a power or not? And I'll show you what I mean in these few examples. So to start out, here we have 4 cubed, so it's just 4 times 4 times 4, which is 16 times 4, which is 64. In part B, I have negative 6 in parentheses squared, so we're squaring the negative 6. I have 2 factors of negative 6. Negative times a negative gives me a positive. This is a positive 36. Compare that to, in part C here, I have negative 6 squared. There's no parentheses around the negative 6. So this means I'm taking the negative of 6 squared. So this is negative 6 times 6, or negative 36. So note that the presence of parentheses or not, up here made this overall a positive 36. Down here, there were no parentheses. So I was just squaring, I was taking the negative of 6 squared, and my result was negative. Negative 5 cubed. Let's see, I've got negative 5 times negative 5 times negative 5, because again that's in parentheses, so I'm cubing the negative 5. Now let's see, negative 5 times negative 5 is positive 25 times negative 5, and 25 times a negative 5 is a negative 125. Now you might be wondering, why did we get a negative here? Up here when the negative 6 was in parentheses, that meant we got a positive 36, and it really has to do with what power it was being raised to. Here we were squaring, here we were cubing, and if you have a negative number in parentheses being raised to a power, your result will either be positive or negative based on whether that exponent is even or odd. And so I'm just going to kind of summarize here our observations. So if I have a positive base, then, and I raise that to a power, then a to the n is positive. If I have a negative base, so I've got a number like negative a, and I'm raising it to the n power. If you have an even power, it's going to be a positive, and if you have an odd power, it's going to be a negative. And then last, if there are no parentheses, then you're just taking the negative of a to the n. That's going to give you a negative. And we've observed all of these in this example. All right, so now we come to the order of operations. I'm going to start with a quick example, one that you may already know the answer to if you have experience with the order of operations. But if I want to know what is the value of 3 plus 7 times 5, one person might look at this and say, well, 7 times 5 is 35, and then I add 3 and get 38. Another person might look at this and say, well, 3 plus 7, that's 10, and then I'm going to multiply that by 5 and get 50. As it turns out, the one on the left is correct. The one on the right is not. And the reason is because when we look at an expression that has multiple operations going on, right? In this case, we have addition and multiplication. Multiplication comes first, unless there's some sort of grouping symbol or something that tells us specifically that we need to do addition first. We do the multiplication first and then addition last. So this solution on the left is correct. And here is the order of operations. First of all, anything that's in grouping symbols comes first. Grouping symbols could be parentheses, brackets, or curly braces. These all mean the same thing. They're just grouping. The last one is a set of absolute values, and absolute values carry with it the additional interpretation that once you're done evaluating what's inside, you make it positive. But it still is a set of grouping symbols. So if there's grouping symbols, we look there first and take care of what's inside. Then exponents come next. At that point, then multiplication and division as they appear left to right. It's not that multiplication comes before division. Multiplication and division as a group, they're like kind of the same type of operation. We just do it as they appear left to right. Same with addition and subtraction. So some people use this handy mnemonic PEMDAS to remember, and so I'm just going to emphasize again, multiplication, division is a group, and we do them as they appear left to right. And the same goes for addition and subtraction. All right, we're going to do some examples. We're going to use the order of operations to evaluate here. In part A, we have a set of parentheses. I'm going to start there first. And things I'm not working on, I'm just going to kind of bring over. -1 minus 6, that is -7. Next comes multiplication. So 3 minus 9 times -7 is a -63. And then minus a -63 is plus 63. And we get 66. Next, here, we can see that we have some parentheses, but there's nothing going on inside, right? There's no operations happening. They're just kind of housing this number. So the parentheses are kind of taken care of. Now we have to turn our attention to the exponents. -3 squared will be a positive 9, and -2 cubed, let's see, that's an odd power, so it'll be a negative. 2 cubed is 8, -8. Exponents are taken care of. Now I'm going to do the multiplication. 5 times 9 is 45. And then 2 times a -8 is a -16. So we have 45 plus 16 because we're subtracting a negative. And that gives us a total of 61. All right, here's another one. Again, we can see we have a set of parentheses at the end, but there's nothing happening inside. It's just kind of housing that number. So there's nothing to do there. So we're going to focus on the exponents first. So I've got 10 squared, which is 100. Oops. Minus 100 divided by 5 squared is 25. Next, now that we've taken care of the exponents, we do multiplication division as they appear left to right. So that means that the very next thing I'm going to do is this division right there, because that's the first one that appears starting from the left. So 100 divided by 25 is 4. And now 4 times 2 is 8. And then minus -3. I'm going to go ahead and just write that as plus 3. Now we're on to addition subtraction, which again we do left to right. So 100 minus 8, that comes first, which is 92, and then plus 3 gives us 95. Next, we have a couple sets of grouping symbols. For starters, I've got the set of absolute values here, which is grouping symbols, and then inside that we have another set of grouping symbols. So if you have grouping symbols within grouping symbols, once you go inside a set of parentheses or absolute values or brackets, like you start the order of operations over again, right? You evaluate what's in there according to PEMDAS. So essentially what that means is when you have parentheses within parentheses, you start on the inside and work your way out. And that means that we're going to begin with evaluating 8 minus 20. And I'm just bringing everything else just straight over. So 8 minus 20 is a -12. And now I'm staying within the grouping symbols of the absolute values. So minus a -12 is positive 12 minus 10. Twelve minus 10 is 2. We have the absolute value of 2. And now I'm going to include this sort of intermediate step and just say, okay, the absolute value of 2 is 2, and 4 times 2 is 8. A lot of people would look at this line and just say, oh, I'm going to go straight there, and that is totally okay. You can skip that middle step. We know that the absolute value of 2 is just positive 2. Okay. In this last example, we've got a set of unwritten grouping symbols. essentially what we have here, and what I want to draw your attention to, is this square root, right? So, we're going to work a lot more with roots and radicals later on, but the square root of a number is just what you get, what you multiply by itself to get what's inside. So here's a little side example. The square root of 9 is 3, and that's because 3 times 3 is 9, right? It's what you square to get the number inside. Now, notice that in the radical here, that sort of ceiling of the radical kind of extends over that sum. And what that means is that's a set of grouping symbols. I have to do that addition first. So 64 plus 225 is 289. And then I'm going to go ahead and square the negative 7. So negative 7 all squared is a positive 49. Next, we want the square root of 289. And it's perfectly okay to go ahead and use a calculator to help you out with that. I think it is 17. And it is 17 minus 49 over negative 4. Now here's the thing, we also have another set of implied grouping symbols. When I have these operations happening within a fraction, any addition or subtraction, or any operations that are happening, any operations at all that are happening in the numerator, we have to figure out what that is equal to before I can do the division that the fraction tells me to do. So even though there's not a set of parentheses written in the beginning, right, I know that there's an implied set of parentheses around the numerator. 17 minus 49 is a negative 32, and now negative 32 over negative 4 is a positive 8.